Hi class, let's start the chapter 4, and it would be about product design. As you're aware, I've done lots of work in especially software product design. So I'm glad to share some of my experience in this field. So let's start uh, this chapter. Now, in this chapter, what we'll be focusing on basically and introduce a product design and describe the design process, name some sources of ideas for a new or revised design, discuss um, key issues in a product design, discuss a special consideration for service design, and then we describe and perform quality function deployment or QFD. So in this chapter, the outline is about a product design process, sources of idea for a new or a redesign a product, key issues in a product design, differences in design services, and quality function deployment. Design services is different than product design. Here is something from Thomas Edison. Genius is 1% inspiration and 99% perspiration. I have not failed. I've just found 10,000 ways that won't work. There is no substitute for hard work. I'll talk about Edison more detail. Product design. It is involves the determination of the form and function of product. In the most cases, the product are redesigned to reinvigorate their demand and to take advantage of a new technology. Idea or inspiration and concept plus effort, exertions, and determination will generate a new product design. Product design process elements about, first of all, a product approval committees. Top management will approve it, oversees and directs, also they will oversees and direct it. They will review it and allocate resources for it. Then you have what you call the core team, which is the cross-functional core team, plan and lead project, and empowered as required. Then you have a phase review, which is occur at the project milestones, approve, cancel, revise the project, recognition or recognizing some problem, fixing them or not, make changes. Then what you call one of the fourth element is a structured development process, which is there is what you call a project management technique, schedule, execute, control of the project. So product design process, in the phase one, we have an idea generation. In the second one, we build a business case, voice of the customer. We do a development of product and process, translate the voice of the customer, testing and validation or proof of concept, and then we launch it. In a gate model, this is the stage gate model of a new product and development design. And there is a link here for it. First, you do a discovery stage, you have an idea screen, the gate one, and then you do the scoping for it. You create second screening for the scope, and you build a business case in this stage two, and then you go and do the development. Development is done, then you try to test it, and then testing and validation. If it's good, then you go launch. And once you launch, post-launch review, you do post-launch review. In other words, from idea to a launch, a typical stage of a gate model. Gate one, which is idea screen, does the idea of merit any uh, work? Like example, we can bring the mobile diabetes. So at the stage is a prelim, the market assessment. We do prelim technical assessment. We do a functional and business assessment and action plan for stage two. At the gate two is the second screening because there's an idea screening now. Second screening, which is does the idea justify the extensive investigation. Here, what we do, we're building a business case. We do a user needs and wants study. We do a competitive analysis, value propositions, define technical feasibilities assessment, operational assessment, product definition, and financial analysis. Now, on the gate three, which is the next stage, we said that the decision to development is the business case sound. So here's why we need to do a development, which is a stage three. We do technical development work, a rapid prototyping types, initial customer feedback. We do a prototype development, in-house product testing. We will do operation process development and full launch and operation plan. Then we get to the describe the test should the project be moved to external testing or is it ready to do that? To do that, we do a testing and validations. So we do an extended in-house testing. We want to know if we can export it to outside. Customer field trials, we do that. We do an acquisition of products, equipment that it's needed. We'll do a production, operation trials. We'll do what do you call test markets, trial, sell, uh, first time users, postal launch, and life cycle plan. After we finalize the launch and operation, we'll do a postal launch. And here we need to answer this question: is the product ready for commercial launch? Not every product is available for commercial launch. And what we do a market launch and roll out, full production operation, selling begun. People start selling it, resell, the result of monitoring what's happening and when we do a monitoring, and we will check the post-launch and life cycle plans underway. What's the life cycle plans there? We're also going to touch on the project management cycle. It's pretty similar to this once we go to the chapter of project management in the future. So, what's the source of ideas for a new or redesigned product? We can collect it from employees. For example, sales and marketing can be a good place source. We can get it from customers as survey or focus group. We can do check it with the competition, what the competition is doing, or how we can better than competition. And here where we do a reverse engineering. So the desampling and inspection of competitors' product to discover product improvement. That's what they do usually a lot in China, and all day they used to do it in Korea and Japan. We check with the suppliers. Suppliers usually have a good ideas also. And we might have a department for a research and development involved in it. When we do a reverse or reverse engineering, basically what we do, we dismantling and and inspecting of a competitor's product to discover what compose and how to component work. Like the case of Volvo's in buying bought by a Chinese company to improve their cars. Now, in the research and development, you do a research, you develop, you do some innovation, and then you go again and you do further research and you make more better further development and improvement on it, and you come up with the final innovation. If it's not, you keep going through these stages. But the research and development, there is a three kind of, few kind of research. First, you organize efforts that are directed toward increasing the scientific knowledge and a product or process innovation. This is what you call a basic research, has the objective of advancing the state of knowledge about the subject without any near-term expectation of commercial application. Lots of them done by the government, militaries sometimes, for their internal use. Colleges and universities do that. Then what you have, what you call applied research, which is applied research has the objective of achieving commercial applications. So how you can produce something that you can make a profit of it or benefit somebody. Then what you have, what you call a development, which is after the research, you have development converting the result of applied research or even the research into useful commercial application. So when you want to search for a new product and idea, I always tell my entrepreneur students in all days, just listen to the customer, market, complaints of people. That's lots of ideas, kids, lots of ideas. Check the gap in the market, exploring the niche market, using new technology, and probably you need to maybe creating a new market space also. There's wonderful videos. I suggest that you probably check the links also for them and the website. Now, the process of or the key issues in a product design, when we are designing a product, we need to look at the life cycle. We need to look at the standardization in the market, the mass customization is needed or not, whether the product reliabilities, how reliable is the product, robust design, which is we will talk about it later, legal and ethical issues, design for environment and material selection. We'll talk current engineering. These are all we're going to cover. CAD, which is computer aid design, designing for manufacturing and assemblies, and component commonalities. These are the key issues in a product design. But when we are looking at the life cycle of a product and services, well, you've learned in the marketing there is early adopters or early users, early adopters, and late adopters. And it this will cause some kind of changing in demand over time up to reach the maturity and saturation and start declining. One of the things that is declining is like, for example, the fax machines or landline over time. The standardization, it's the extent to which there is an absence of varieties, and we use Six Sigmas usually to do some standardizations in a production, in a product, service, or progress. And the advantage of standardization, you will have economies of scale, reduce cost, because there's a standard product that you're producing, cost in the production and purchasing. There is a design time spent on improvement. You don't need to always do lots of improvement. And there is a reduced training cost and time because it's a learning curve which is diminishing as time passes by. The disadvantage is reduced variety limit range of customer because you have a same cup, red or blue, design of frozen, permanently resist the modification also. So when you're designing for a mass customization, it's a different when you're designing one product. It is a strategies of producing standardized good or service, but incorporated some degree of customization. And you see that recently in probably in some countries for car design, you will find lots of customization these days when it's coming, even with the Nike trying to do lots of colors and shape design, customization. But there is a delayed differentiations happening, and there is a modular design step by step, which is might cause time and effort. In the delayed differentiation, we see that producing, but not quite completing, a product or a service until the customer preference are known, a postponement tactic. And that's done to cover this, differentiation. You can use the agility project management also. So you can, it's not final, you can design them further and further and develop them. That's one example. Tailoring, as you see here, that's one example. Kind of a customized food that you're looking for. In the modular design, a form of standardization there. Parts are subdivided into modules. Modules easily replaced or integrated. I think Dell is really good at that. They have so many lines of products within their PCs and more laptops, and it's depend the sizing, the RAM, the screen. They can assemble different products together. The advantage include easier diagnostic and remedy of failure. So it's easy to find out where is the failing happening, how you can fix it, easier repair and replacement. So you can take if the RAM that doesn't feed is match the processors, then you probably need to adjust it. Simplification and manufacturing and assembly. The disadvantage, you may need to scrap entire module if there is a faulty. So especially in cars, sometimes you scrap big certain part of the cars if there is one small piece is faulty there. That happens a lot in airplane industries. The reliabilities. Reliability means the ability of a product, part, or a system to perform its intent function under prescribed set of conditions. So you set up the conditions and you see that should be operating that. This person bought a car, speeding car, takes it back and says, after 300 kilometers, there is a little bit shaking in the car. I told him, why are you driving 300 kilometers speed? So the reliabilities for people is, different. And that is what you call a failure. A failure is a situation in which a product, part, or a system does not perform as intended. You're always going to do some improvement in the reliability. And to do that, you need to take a look at the individual component, whether the production or assembly procedures happening properly, has been done enough testing on it, redundancies and backup if there is a good system design or you need to redesign some part of it. User education, as we said, you know, the user has to be having a knowledge of how to use the product properly, and preventive maintenance procedures that you need to do. For example, in cars, it's after 50 kilometers or something like that, or 5,000 kilometers, you need to change certain parts. Now, when we talk about failure, failure is a situation in which a product, part, or a system does not perform as intended. This includes not only instance in which the item does not function at all, breaks, but also instance in which the item performs is substandard or its function is not not intended. So the product is not performing 100% or is not the way intended to. Now, what we have called, we spoke about, we said that we're going to talk about the robust design, which is a robust design that can function over a broad range of conditions, very cold, very warm, for example, in the cars. Uh, the Tokchi or robust approach is to improve the quality of manufacturing goods, recently applied to other fields also. There's lots of uh, uh, examples that is maybe developed by the military, US military, and used for commercial good to make it better. It is easier to create robust design than control the environment factors. So we need the tires that is good for winter and is good for summer. It's easier to produce that than make sure the car is always driven in the summer. The center of features is parameter design. Once again, you need to put a parameter. You determine the parameters, the factors that are controllable and those not controllable, their optimal levels relative to a major product advances that we need to take a look at them before we produce them. That comes in the fact of when it comes to product design and service, the ethical and the legal issues. There's always government bodies and ethical issues that oversees these things. We saw in the food, there is a Food and Drugs Act, or in USA is Food and Drug Association. There's a Canadian Environment Protect Act. We have the Motor Vehicle Safety Act for Transportation Canada. We have a Hazard Product Act, which is industry. There is what you call, there is a patent, there's a trademark, copyright violation, and then there is what you call the ethical, which is releasing product without defect, with a defect, and also the environment issues like a burning car. So, so the design for environment, when we're looking at the design, we have to take into consideration the environment. We're looking for energy efficiencies of product. We're looking for energy efficiency used in manufacturing, whether there is a hazard, minimize materials and how we minimize it. Emission and waste in manufacturing, very important. We saw how does the Ford do that. Biodegradable, disposable, and packaging. We saw also earlier classes how they do that for cartons. reuse, including the packaging, disassemblies, and remanufacturing. And we talk about recycling, which is including the packaging, reuse, recycle. These are issues that today's trend. So the design for environment, we said that's remanufacturing, which is refurbishing used product by replacing the worn out or the defective one with a new one. We saw that lots in the computer sometimes. Design for deassemblies, design so that you use product can be easily taken apart, simple like once again the computer we can take it apart and pick the good ones from the bad one, whether we can do a recycling like Starbucks cups, recovering material for future resource use, and a cradle to grave assessment of the environment impact on a product or a service through its useful life. How this product can hurt the environment. Now, when we do a material selection, we have to do a careful consideration for the material selection is always important for achieving the performance and cost objective of any products. We always in a business to balance two things, maximizing the profit and taking into consideration the stakeholders also. If the material selection is not done properly, the performance of a life expectancy of a product may be highly unpredictable. Like the cheap car tires, sometimes you see that as a good example. A design may look good on paper, as usual, but fail to work properly in a real world situation. So, when you do a product requirement, material experimentation, and then you do a material selection. Concurrent engineering. There is something called over the wall approach. You do a design, you throw it to the engineer or manufacturing and says, produce this for us. And usual manufacturers have no idea what is happening. But in the concurrent engineering, bringing engineering, design, manufacturing, marketing, and purchasing stuff together in early design phase, that all of them work together to come with a perfect product or a competitive products. In the design for manufacturing, first of all, what we have something called CAD or CAD, computer aided design, which is a product design using computer graphics. And then we have what you call DFM, which is designed for manufacturing. And it's basically designers take into account the organization manufacturing capabilities when they are designing a product. And then you have the DFA, which is designed for assembly, is a different than you design a product. And it's because design focus on reducing the number of parts in a product and on assembly method and sequence. And then you have what you call component commonalities, which is use same internal component for a variety of product, like we do chassis in the cars. Now, in the case of CAD or computer aided design, is a product design using computer graphics. And in this way, we can increase the productivity of designers 3 to 10 times. We can create a database for manufacturing information on a product specification when we are designing it as with a CAD. We can produce or provide possibility of engineering and cost analysis of proposed design. What if we move it, change the color, make it smaller, make it larger? All these things can tell you the cost analysis or different possibilities of design. In the DFM and the assembly, we look at what you call manufacturability. And it's about a key concerns for manufactured good, whether it's easy of fabrication or easy of assembly is very important for cost, productivity, and the quality itself. So the DFM or design for manufacturing is considering organizations' manufacturing capabilities when they design a product. In the design for assemblies, which is different than DFM, it is when they are focuses on reducing the number of the part in a product on assembly method and sequence. And then you have the commonalities or component, as we said, multiple products or a product family that have higher degree of similarities can share component, like detergents. In the component commonalities, companies can realize significant benefit when a component can be used in a multiple product. For example, we know that the car manufacturing in Ford, for example, car manufacturing is the same chassis or platforms and internal components such as engines and transformation and several methods. They do that in Toyota also. We see that in computers as well, especially in Dell. Softwares, chips, and circuit board, all in computers. But what we said in the beginning of this book, in this class, we talked about the difference between goods and service. And here, once again, in designing, there is a difference between goods and service. As you know, services are intangible. Ambience, convenience, image. Service created and delivered at the same time. You cannot be inventorized or fix the beforehand. Service disappear right away if nobody uses it. Training, process design, customer relation important. These are very important, and the service are customized, especially in the high end, like colleges, like legal, like doctors. They're highly customized. Services have a low barriers. That's one of the things that challenging to entries and exit. And location is important too for the service design. Have a single unifying theme, such as a convenient or a speed. That's a design for the service when you're trying to design, whether you're designing a speed or a convenience. Means beside your home, speed is once you go in and out very quick. Make sure the system has capabilities to handle variabilities in the service requirement. You have some kind of prediction plus, you do a variance requirement, include design future and check for reliability and consistent qualities. If you go to the supermarkets these days, due to the COVID, there is a different lineup you see for the cashiers. We can talk about it and design the system to be a user friendly self-service like in stores. There is a job which is somebody is involved in doing the blueprint, which is called service blueprinting. It's a useful tool to conceptualizing a service delivery system. There is a wants and needs, there is a customers, and there is a system, and how we can deliver that. There is a method for describing and analyzing a service process, much like an architectural drawing. Service blueprint shows the basic customer and the service action involved in a service operation, how the field, the flow, timing, how long an each stage will take. You need to, it is all showing and the feedback from it. This is what you call a service variabilities and customer contact. There is a high customer contact, low customer contact, different service, standard service. They're all taken into consideration. So variability in service as it goes high, the degree of contacts with the customers and it's high, that's a different, it's like a customized clothing selling or a legal department, highly customized. And on the other hand, which is there is a minimum customer contacts and minimum customization. It's what you call the internet selling, which is a highly a standard one. Internet selling now, for example, Nike is coming with a customized, but it doesn't need you doesn't take that long. Person can go online and customize it. Quality function deployment, which is a QFD, is a structured approach that integrate the voice of the customer, what the customers want, into the product design, how strong, stable the product. It's to translate the customer requirement into a measurable technical terms or specification, the speed, the weather, resistance, all these things. It's a set of metrics you put in, basically, and it's a house of quality. We're not going to talk so much about this part of it, but this is a part where you do FMEA, FEMA analysis. FMEA, or failure mode and effect analysis, is a method for identifying possible failure in a product or a process. Testing, then assessing their effect in order to find the opportunity for improvement. Like we do looking at the suppliers, who is supplying what, and possibilities of failing and what's the side effect of failing. The failure mode portion asks, what can go wrong if this fails? The effect analysis, like a brakes in a car, what can go wrong? Nothing. People dies. The effect analysis portion refers to studying the result of those failures and ask, what would be the consequences of the failure for the customer? So these are the steps where we do FMEA analysis. We identify the function of the product or the process. For each function, identify all the way failure could happen. For each failure mode, identify all the effects of the failure for the customer. For each effect, determine the severity rating, which is for the S, which is typically on the scale is from 1 insignificant to 10 catastrophic. For each failure mode, then we determine all the causes of the failure. For each cause, determine the occurrence, which is typically the scale from extremely unlikely to extremely 10. It will happen in an eventful. And then for each cause, determine the control mechanism currently in a place to detect the failure. And then for each control, determine the detecting rating, how we can detect that. This is rating estimated how likely it is the failure can be detected before the customer is affected. Now there is an applications and hardware who does that. IBM do that very good, very well. And then we do a calculate the risk priorities or RPN for each cause based on severity of the effect, frequency of recurring, and detection rating by multiplying these three together. When we do 1 to 10, and we can multiply, then we can standardize it. List the PRN in descending orders. What's the highest, what's the lowest? This highlights the cause with the greatest need for improvement. Then we do identify the recommended action to lower severities or occurrence of failure or improvement their detections. As the action are completed, keep updating the SOD rating and the new RPNs. So in this chapter, we talked about the design process involves market, competitor analysis, goal setting, such as product performance goals, qualities, and quality function, deployment, concept design, and product. We product specification and building and testing prototypes. We also spoke about the design idea can come from the customers, employees, suppliers, competitors, research and development. We talked about the stage of life cycle of a product influencing the nature of its design. We touched on using standard parts and common modules save operating costs, but it is possible to provide some mass customization by allowing customers option on a modules and postponement like a tailoring or a Dell. And then we spoke about the reliabilities of well-designed product has to be extensively tested and improved, and it might be cheaper to design robust product that perform consistently in varied productions and use conditions. It is faster or cheaper to predict to the product team to perform a product than throw it over the wall as you've seen it. We utilize CAD has helped to reduce the design time. It's cheaper overall to design a product that have a fewer parts and are easier to manufacture and assemble. Services needed to deal with the customer's presence and involvement, and we spoke about them, how to do this, and inherent varieties of the services, what kind of a services, how long it takes, customize, more contacts or less contacts with the customers. We spoke about QFD, which is a multifunctional process for a product design that start with a voice of the customer, what the customer wants, and end with its translation into a product characteristics, like what they did in Ford in the early days when they discovered, when they invented the car. Failure in manufacturing and service, their mode, ways to fail can occur and effect. We use FEMA of MEA analysis to see how we can avoid that. These are the checklists. You can take a look at them and check whether you have understood all these parts later on when you go through it. Thank you.